Okay, today we're going to do congruent segments and distance formula. This one's going to be a little longer than the last one because there's a little bit more information. All right, so first things first, the essential question is how can you measure and construct a line segment? So we're going to use the ruler postulate. We're going to use segment addition postulate. We're going to use the distance formula, which you'll be receiving your formula charts today, and copy segments and compare for congruence. So vocabulary, the first definition, a rule that is accepted without proof is called a postulate or an axiom. So they're the same thing. So you may see them named postulates, you may see them named axioms. Either way, they're the same thing. So they're just accepted to be true regardless. So the first postulate we're going to look at is the ruler postulate. The ruler postulate states the points on a line can be matched 1 to 1 with real numbers. So this would be the first point, this would be the second point. The real number that corresponds to it is the coordinate of that point. The distance between 2 points, A and B, written as AB. So if you see something that says find AB, they're wanting the length. So they're wanting length. So make sure you know this. So they're wanting length. All right, so you want to do the absolute value because distance can never be negative. Distance can never be negative. So we use absolute value because that makes it positive. So all you do is you take the first point. I always do first point minus the second point. So I would do first point minus the second point in the absolute value. You can do second minus first. It doesn't matter either way because it's the same distance no matter which way you go. All right, so if we find the length of MN, obviously, yes, we can count. 1, 2, 3. Yes, our answer would be 3. But using the formula, because you're not always going to have a number line or small numbers, so you want to go first number minus the second number, so M and N is 4, and you want the absolute value. Well, 1 minus 4 is negative 3, and the absolute value of negative 3 is simply 3, which, duh, we knew that. First number, negative 2, minus the second number, 4, absolute value. Negative 2 minus negative 4 is negative 6. The absolute value of negative 6 is 6. So we could count 1, 2, 3, 4. Did I do L? Oh, I messed up, not K. 1, 2, 3, 4, 5, 6. All right, there we go. 6. All right, the next one is called segment addition postulate. Basically, it says this piece plus this piece equals the whole piece. So you get AB plus BC equals AC. So part plus part equals whole. So can you draw a sketch to show what it would mean if point B is not between? So if you want one that's not between, so you have points A and C. So here's point A, and here's point C, and point B could be out here because we just simply want one that's not between. So let's get rid of that. So here's point B. So point B is not between. So one solution. In between, the word between does not mean middle. So between does not mean middle. And I don't know why it's writing with an eraser, but okay, whatever. Go with it. All right. So let's find the measurement of these two. So they're wanting the length of DF. Well, obviously DF is going to be DE plus EF. EF equals DF. Okay, this is going to take forever if it keeps doing that. All right, so DE is 23 plus EF is 35. So that would be 58. So 58 equals DF. So they're super easy when they're like that. Oh, goodness. Let's try this again. All right. So 58. We'll just do this. All right. What about xy? They want this piece right here. They want you to find this piece. Well, I know that xy plus yz equals xz. I know that for a fact. I know that 3a plus 14 equals 41. So part plus part equals whole. So subtract 14 from both sides. Doing your basic algebra, we get 3a equals 27. Divide by 3, a equals 9. Well, since a equals 9, 3 times 9 is 27. So that makes xy 27. All right. Point E, F, and G are collinear. Remember, collinear means all on the same line. So they are collinear. This is important. So point F is between, not in the middle, but just somewhere between E and F, or sorry, E and G. So you draw a line. There are 3 points on this line with E and G, and then point F is just somewhere on here. All right, so let's see. It says EF is 4x minus 20, so this piece is 4x minus 20. FG is 2x plus 30. And EG, which is the whole thing, is 100. So knowing this, then I can do EF plus FG equals EG. So see, sometimes not like before when it was obvious, sometimes it's less obvious. So EF is 4x minus 20. FG is 2x plus 30. And together it's 100. So combine your like terms, I get 6x plus 10 equals 100. Subtract 10 from both sides. So 6x equals 90. Divide both sides by 6. X is 15. So it says find the value of FG, so they want the value of this. So 2 times 15, because X is 15, plus 30. So 30 plus 30 is 60. So FG is 60. So if this piece is 60, then I know this piece is 40, because remember they have to add up to 100. Okay, then we have our distance formula in the coordinate plane. When you have your distance formula in the coordinate plane, it's not as easy as just counting 1, 2, 3, 4 and 1, 2, 3, 4, because now you're slanted, so you have to use this formula. You always want to label your points as x1, y1, x2, y2, and so on. So I'm going to go x1, y1, x2, y2. And then you just plug them into the formula. The great thing about the formula is it tells you what parts to use, what to do with them, where to put them. It's very obvious. So AB is the square root of x2 minus x1 squared, y2 minus y1 squared. So just plug and chug is all you got to do. So we've got x2 is 7 minus x1 is 13. Y2 is 10 minus y1 is 2. And don't forget every piece, squares, pluses, everything. So 7 minus 13 is negative 6 squared. 10 minus 2 is 8 squared. Negative 6 squared is positive 36 because you square both pieces. 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10. So AB is 10. Same thing over here. So this is x1, y1. This is x2, y2. I'm not going to write the formula again. I'm just going to use this right here. So x2 So 3 minus negative 3. Notice the formula calls for a negative and it's negative here, so that means you get double negative. y2 minus y1 squared. Well, when I have two negatives, they turn into positives. Don't forget that rule. So 3 plus 3 is 6 squared. 2 plus 2 is 4 squared. So I've got 36 plus 16. 36 plus 16 is 52. And the square root of 52 is about 7.2. So EF is about 7.2. All right. Now we have congruent segments. Anytime something is congruent or equal to each other, they're going to have matching tick marks. So they may have two tick marks, they may only have one, but as long as their marks match, that means they're the same. When you see equal signs, it means it's equal to. When you see the equal with the squiggly, that means it's congruent, which they basically have the same definition. But when we're talking equal, then that means you know the actual length. Congruent just means I don't know what size they are, but I know they're the same. So let's plot the point J, K, L, and M in the coordinate plane. So negative 3, 4. So negative 3, 4 is right here. So there's J. 1, 1 is K. Negative 1, negative 3 is L. And 3, 0 is M. That is not looking right. Negative 1, negative 3. So J, okay, now let me connect these lines. J, K, 3, 0. That's not right. Okay, there's two separate line segments. Okay, I was thinking I was supposed to be drawing a box of some sort. All right, makes sense. All right, so here we go. We've got it says use the distance formula to determine if these two segments are congruent. Well, of course, if they were horizontal or vertical, they'd be super easy because then you could just count 1, 2, 3, 4, and so on. But what's cool about them being on the coordinate plane is they're real easy to check because you can use Pythagorean theorem. I could draw this triangle here and I see that this is 1, 2, 3, and this is 1, 2, 3, 4. So this has a length of 4, this has a length of 3. So I could say that JK is 3 squared plus 4 squared. Take the square root. So 9 plus 16, take the square root, which is 25. And the square root of 25 is 5. So that means that JK is 5. And to do the same thing with LM, just draw my little right triangle on here. So I get 1, 2, 3, 4. So this is 4. 1, 2, 3. So this one is 3. So again, I've got 3 squared plus 4 squared. 9 plus 16 is 25. And the square root of 25 is 5. So then that would be my explanation. So I'm going to, the length of this and the length of that would be this, what I just did down here. So my explanation is that JK and LM have the same length. So have the same length. So JK is congruent to LM, period.